Hi everyone, welcome to Math Learning Hub. So today we're going to be solving this equation where 6x plus 4y equals 4 and x and y have to be integers. So find the set of solutions to this equation. And so this is what we call a Diophantine equation. Basically, it's a equation where you have multiple variables and you're trying to find the number of integer solutions to the equation. So the equation might not be fully restricted, i.e. it might not only have one or only have two solutions, or it might have one or two solutions. But the main thing here is Diophantine equations have integer solutions. You're looking for the integer solutions that satisfy it. And just a quick thing to know, this video assumes familiarity with mod. Yeah, so that's just something that you would need to know to understand what's going on. So let's dive into solving the problem. So first thing I'm going to do is subtract 4y on both sides to get 6x is equal to 4 minus 4y. And now what I'm going to do is take both sides mod 4. Okay, so what happens when I take both sides mod 4? Well, 6x mod 4 is 2x because 6 mod 4 is 2. And that is equal to actually 0 because 4y mod 4 is 0 and 4 mod 4 is also 0. So 2x equals 0, of course, mod 4. And since I'm doing mods, I should probably make these equal signs to triple equal signs. But yeah, so this is 2x equals 0 mod 4. And then from here we can divide by 2 to get that x is equal to 0 mod 4. And so what does this mean? Well, from this we can actually get one solution. Any x that is 0 mod 4 would actually satisfy this equation. So for the sake of simplicity, let's just take x equals 0. So what is y when x equals 0? Well, 6 times 0, like plugging it back in here, 6 times 0 plus 4 times y equals 4. So in that case, y would be equal to 1. So one pair of solutions, x comma y, one pair of solutions would be 0 comma 1. And this is one pair. Okay. And then so how can we find the other pairs of solutions, or how can we express this in a way where it encompasses every single solution? Well, let's consider this equation. What about 6x plus 4y equals 0? Right? Because if we have something, if we can express this equation in a way and get a solution x comma y is equal to, for example, written in terms of constant k, for example, nk comma mk, where k is an arbitrary constant and n and m are integers, then when we add this results to over here, for example, we can get, for example, nk plus 0, comma mk plus 1. This would actually be the set of all solutions to our equation. So I'm going to actually demonstrate this by actually solving this equation. So 6x plus 4y equals 0. Again, you can move this to the other side to get 6x equals negative 4y. And then simplifying, this is 3x equals negative 2y. And then you can evidently see that the set of xy solutions to this is going to be, so x comma y, that is going to be equal to, for example, an arbitrary negative 2k and then 3k. For example, this means that if you had a number k, any integer k, for all integer k, so for all integer k, if you had an integer k and you subbed it into this expression, this would satisfy this. And when you add this solution here to this solution here, you're actually going to get the set of all solutions. So stop and think about that for a minute. Because we got this one here from 6x plus 4y equals 0, right? So this is the sum of all solutions for 6x plus 4y equals 0. So essentially you're adding nothing to your final equation while also like getting more solutions. And this is one solution to the equation. So when you add these two, you actually get the set of all solutions to the equation. So stop and think about that if that doesn't make sense. But so the set of all solutions to the equation is x comma y is equal to negative 2k plus 0, which is just 2k, comma 3k plus 1. And that's just going to be your solution for this problem. So yeah, this is just a quick intro to Diophantine equations and just how to solve this simple one. I hope you enjoyed the video and learned something new, and please be sure to subscribe if you did. Thank you so much, and see you in the next one. Bye!